rules are important. Probably combined with the word list, the rules are probably the most important technique to learn, because when the two are combined together, things can get really interesting. You can come up with some rules in a relatively small amount of words, and you can really run through hashes wholesale. And so let's talk about how to make some of the simple rules, because making more complicated rules actually follows the same process. You just build upon what you learn and gradually, slowly add a little bit more to the rules to make them that much more complicated. But they all start off with some basic primitives. When you make a rule, you put it either in the john.conf file, or you can optionally put it into a different file if you want to, and include your file in the john.conf file. At the end of the day, somehow either the rule has to either be in the conf file or you have to refer to it in the conf file, so it flows through the conf file. Of course, you saw some rules earlier that are in the conf file by default. We had the single crack and word list rules that we looked at. And those are good starting places for kind of learning how to read the rules and the rule syntax. Again, we want to emphasize that we want to use lowercase word lists that have been unmangled and unique. And we saw earlier how we would very easily approach that problem. To make a rule, the syntax is the following. So you start off with a directive called list.rules, colon, and then the name of your rule. You just need to be careful to pick a name that hasn't already been used, but otherwise names are pretty much alphanumeric. Underneath of your label, you put the rules, one per line, one after the other. Pretty straightforward. There's a good document that explains the rule syntax. It's actually so good that if you're going to write the rules, I'd actually download it and probably like print it out. Or at least print out the top part that has, the basic primitives to make the rules, because it's super good reference on how to put together some rules. And you can combine multiple primitives into a single line to make a hybrid rule or super rule or whatever you want to call it. A rule that does more than one thing. So as an example, let's make a rule called append one digit, and that'll be our label. And this rule wants to put each of the numbers 0 through 9 on the front, or excuse me, the back, the tail of each of the words in a dictionary. And in addition, we're going to make a really complicated append one digit rule that actually will do something else too. So the second part there will capitalize the word first and then append the digit onto the end. So if you had the word password, it would create password 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then capital P password 0, 1, 2, 3, 4, 5, 6, 8, 9. And the syntax is definitely the trickiest part. That's where the learning curve really is. So here we can see that the capital A followed by the Z means put it at the end. Now, it's a little bit of a trick. The A means insert this character here. Z is just a shortcut of saying the end. You could say A0, meaning put it right up front. In other words, prepend it. Or A2, meaning put it after the second letter in the word. So A means put this digit here, the Z means the end, and 0 through 9 is the stuff to put. You can also use ranges, like in this example here, I didn't type 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I put 0-9, meaning 0 through 9 inclusive, and John is smart enough to expand that idea into the 10 digits. So even some very simple rules are pretty tricky, right? There's quite a bit going on here, even though this rule here is simplistic. And that's why, again, I recommend get the rule cheat sheet and print that thing out and keep it next to you, because it is tricky. So, but if for today, I'd like you to at least learn the A rule, which means put this here, in this case a Z, Z meaning end, and then 0 through 9 is what I'm putting. And I'd like you to learn the C rule, which is capitalize, and I'd like you to learn one more that's not listed here, the U rule, which means uppercase. So one special rule is that colon, I mentioned earlier, it means do nothing, the no op. It is just take the word as it is, don't change it, don't mangle it, just try it the way it is. Because you don't want to have a rule that doesn't include the no op, because then you're not going to actually try the word as is in the file, which would be kind of silly, right? Never know, you might get a hit.
Jeremy, you're probably going to answer this, but what's the difference between uppercase and capitalize?
I'm sorry, uppercase and capital...
Capitalize.
Oh, the question is, what's the difference between uppercase and capitalize? So capital P, but lowercase ASSWRD is capitalized, and then capital P, capital A, capital S, capital W, et cetera, is uppercase. Yeah. So uppercase, all the letters in the whole entire word, wherever they are, whatever position, they're all capitalized. And capitalized word is just the first letter. Some people call it sentence case, meaning the first letter of each word. So now this rule here is going to expand on what we've learned so far, and this one gets to be more complicated, and this is the append and prepend year. So we're going to actually make up a new rule, and this new rule is combining different ideas under the same label. So a single label is allowed to do multiple things. Just put each rule one at a time on each line and separate them by hitting the enter key and putting the next one down on the next line. So we have an A0. Remember I said 0 means beginning, right? It's the first position. And then AZ, which means the end. And we have a CA0 and a CAZ. So this one's going to prepend 201 hard-coded, and then it's going to iterate through 0 through 9. So it's going to print 2010, 2011, 2012, 2013, all the way up to 2019 on the front. It's going to do the same thing on the back of the word. Then it's going to capitalize the word and put the numbers on the front, and then capitalize word and put the numbers on the back. When you're prepending things, be careful about the order that you say to do the commands in. So it's going to read the rule from left to right. So the third one down, capitalize and then prepend the word on the front, means capitalize it first and then prepend it on the front. Now, it won't necessarily get you in trouble on some rules because the order doesn't matter. But on a rule, if you were to prepend a number first, think about it. You got a word password, it's lowercase. You put a number on the front, 2010. So it's 2010 password. And then you say, after you do that, you then say capitalize. Can you capitalize a number? No, the number is not eligible to be capitalized, right? It doesn't have case. So the rule is not going to work the way you think. So you have to be careful. Just think through the rules. Most important thing with rules, test. Test the rule. If it's not working, you want to make sure you know that before you try to use it. So, and they do take a little bit of practice. Okay? So let's test. Let's give it a try. So I'm going to copy these commands. These are familiar. I'm going to echo the word password into temp password. Oops, sorry, that went a little crazy. So I had echoed the word password into temp password, and then I'm going to cat temp password to make sure that the password's in there, and it looks like it is in there. Oh, it looks like I put Microsoft quotes around it, so let me fix that. So Microsoft quotes copied from PowerPoint they're not the 20-second character or whatever. So, but that's why you cat things out to make sure. All right, that looks like that's working now. Okay, so going back to the slide, I'm going to try to make a rule, and then I'm going to test this rule using the exact same techniques that we had learned earlier. So I'm going to introduce a new directive here. It's called the -- rule. Actually, I think that should be rules. And then it's the rule name. We've seen standard out before. It just means don't try to actually crack any passwords. Just print what you were going to do to the window. And then we've seen the -- word list before, and it's pointing to temp password. So in other words, we're going to run the rule on these words that are in this file called temp password. There's only one word in there. And then we're going to see the mangles. We did this earlier with the single, but we hadn't introduced the concept of making our own rules yet. But this is an extension of that experiment that we did with the single. So the first thing I got to do is go write a rule. All right, so I'm going to use gedit. If you want to use nano or v or whatever, feel free. But for the Windows folks, this gedit's going to be a bit more friendly. I go to opt john run john.conf. And I like to keep my rules at the top of the list of rules. It makes them easier to find, and then I just kind of know where they are, and I don't have to search around. So there's a rule that is going to be in the file called the none rule, and it's what it sounds like. It's the no op rule. It's there by default. It's one of John's default rules. And I usually just, for no particular reason, I usually just put my rules after the none rules just because that's where I put them, and it's not right or wrong. It's just I know where they're going to be. So you pick a spot, but that's not a bad one. Oops, sorry, I got to get this Control-C. All right. So if I were going to make a new rule, I usually copy a rule that's already working, and then I'll just change the label. And so maybe, since I've already made the add one digit rule here, I'll make the add one digit to rule, which does add one digit in a different way. So this syntax here is perfectly legitimate. A $sign means the end of, so does AZ. Two different ways to do it, both equivalent. I'm going to make my add one digit rule use the AZ that we looked at earlier. And we were going to do AZ, and then we said 0 through 9. You can also do it this way. All this 0 through 9 syntax was just a shortcut way of saying 0 through 9 inclusive. So this actually will add 2 digits, technically. So let's just do that. I'll just change it to 2 digits. So it adds 2 digits onto the last position, which is the zth position, the last position. Z is a stand-in for whatever the last position is. Okay. I wouldn't recommend writing rules all crazy like this, but just making a point that there's more than one way to do it. So.
Oh, so you wouldn't actually ordinarily write it like that. You just put 0909.
Yeah, just for fun.
Or you're just showing that. Okay.
I'm just showing you can do it this way or you can do it this way, and they're equivalent. And just to prove they're equivalent, I'll have the first letter come, or first digit come this way, and the second one be the expansion. John has something called a preprocessor. It actually transforms the rules into a common syntax. It compiles them, for lack of a better term, into a standard format anyway. So when it gets done, it's gonna massage it into a nice, clean format anyway.
And will it also catch errors, I suppose, before they?
It catches some logical errors, but I'm sorry, some syntactical errors, but not logical errors.
Just conditions the rules a little bit.
Yeah, it gets some. It's kind of like Java does with bytecode, sort of. It basically pre-processes them. So it'll catch syntax errors. It will not catch logical errors. So if you try to include a file that doesn't exist, it'll catch that. If you try to I don't know, make a rule and you don't give it a label or something like that, it would catch that. But it's not going to catch things like, I named my label wrong, or I didn't write the rule I expected to write, or my rule doesn't make any sense. It's not going to catch any of that kind of stuff. So add 1 digits and add 2 digits, good enough. All right. As far as capitalization goes, you can just write it lowercase, actually, which is kind of interesting. And, oops. I am in the documents directory, and that's not going to do a lot of good. So instead of trying to use the shortcut, let me write it all the way out. Op John run John, and I think the Microsoft quotes bit me again, or the quotes. So let me take those out. So we'll just keep testing this until we get it right. And I shouldn't have had the quotes in there, I think, is the problem. Gonna try again. You just keep iterating over this until you get it the way you want it. Can't emphasize enough. Test and test some more. So, oh, I bet you I just had the wrong quotes in there. All right. Let's see. I'll cheat. I'm gonna look. I did it this way. This one always works. There we go. $sign is another way of saying at the end of. All right. If anybody sees what I'm doing wrong, let me know. Let's see. Let's try this. We'll go back to the last known good state. I'm going to try add 1 digit. See if I can get the demo working. Oh, you know what? I bet my password file's messed up. It's probably not the rule. The rule's probably fine. Yeah, I got the Microsoft quotes again. I should have stuck with my first inclination that I had messed up the Microsoft quotes. Duh. So I go with the most obvious. Okay. Let's see. We wanted to do like something like that just to show AZ. I'm going to try to make it this way. It's not exactly the add 1 digit rule anymore, is it? I'm sort of butchering this thing. But we're just playing. Okay. So let me go back and kind of clean up this file a little bit. All right, so let's do an add 1 digit rule. Probably the simplest way to add 1 digit that I know of is probably $sign, which is equivalent to AZ. And then 0 through 9. I think that's the shortest. Can anybody write one that's shorter? Somebody know how to write one that's shorter than that?
Add a digit.
I guess you could technically do it this way too. Yeah.
If it has classes, like
Yeah, it does have classes. Yeah, it does have classes. The classes are at the top, a little bit beyond the scope of the class. Drum roll, or sorry, rim shot. But yeah, the classes are up here. So here's like 1, 2, and 3. I'm sorry, Matt. Those are masks. You said classes. Here's the classes: 0, 1, and 2. And then you can add more classes. So classes are way, I don't want to call them regular expressions, but they're like collections or groups. Yeah.
all of the kind of like the close to lowercase and uppercase.
Yeah, it's this for the simple stuff. It's not entirely different than regular expressions. Exactly, it does diverge as you get into more complicated rules. It starts to really veer off of regular expressions. But with these more simple things, yeah, there's definitely some overlap. I'm going to make an add 2 digits rule just for fun. I mean, and then I'm going to make this one. This one's going to be like super fancy. So like, let's do. So we'll add the 2 digits, and then let's capitalize, and then let's get really crazy. So we'll write like a third variant that'll do uppercase. So now in the add 2 digits, let me kind of scroll this up a little bit. So now in the add 2 digits, we've got 3 variants. We have the uppercase add 2, the capitalize add 2, and then the just plain old add 2, right? So now we're just Just trying to get some good variance going. All right, and that was the add 1 digit, and then let's do the add 2 digits. I think it had an S on the end if I remember right.
It did not.
It did not? Okay. Thank you. Oh, let me try. Yep, you're right. It didn't have the S, and I butchered the rule. You definitely have to test an absolute ton. Try again. I think the way I think I forgot the little $sign after the first set. Like I didn't copy that over. These all do the same thing as far as the AZ goes versus the $sign. But I had my mistake was I had a $sign followed by 0 through 9. But I didn't put the $sign for the next 0 through 9 to say, you know, like I pinned that one too. And then take the S off the end here. Probably need to pipe that through less. That went by pretty quick. So we can look at it a little bit closer. So we have password 00 through 27 on the first screen. It's not uppercased or anything yet. Now, once I finally get to 99, where the odometer flips over, it then starts the capital here with 00 again. And then let's go down to the next 99, which is here. And then, again, the odometer flips over, and it starts to do the uppercases. And then when we get to the end, it's done. Okay, now let's combine this with the word count we talked about earlier, so WC-L counted lines, if you recall it counted lines of things. So if we pipe the output of the standard out of John into the word count-L, we can see how many words we generated, and it generated 300, not surprisingly in this case because it's a relatively simple rule that we can do in our heads, but believe me, when rules get complicated, you have no idea, right? And you want to see what kind of level of effort you're getting. All right, so that is the very basics of rules. And that was bonus. You got to see like 12 ways to do it wrong. So, all right. So we went through this exercise testing the append 1 digit rule, and we talked about how to write the rules. Now this is pretty interesting. So we wrote, in our case, in the example here, it says append 1 digit and append and prepend year was the 2 examples we walked through in the slides. In the real life, we did the append 1 digit and the append 2 digit rules. And we could make a pseudo rule or a mega rule or a meta rule or whatever you want to call it. But we could say a new rule that has the label both my rules and then do the dot include both of those rules into one like super rule, or basically it'll run the one set of rules. When it gets done, it'll turn around and it'll run the second set of rules. But it'll be back to back. And it's a way of organizing your work into a much smarter way of not repeating rules that you've already written before, but just packaging small sets of rules that do a very specific job and packaging them together into a bigger rule without repeating the cutting and pasting the work you've already done. You really shouldn't cut and paste the rules, because if you make a mistake, then you got to go find all the places you did it. So this is a better, more organized approach. All right. Now this gets really interesting, is you can include rules from other files. So John, by default, actually comes with the core logic rules, but they're often in the core logic file, corelogic.conf. At least the jumbo version of John. And you can include those rules if you go into your john.conf file. You don't have to open up the corelogic.conf file and copy all of their rules and paste them into the john.conf at the bottom or whatever. You can just refer to the core logic file and pull it in that way by adding a line like .include john corelogic.conf. And in fact, we can see an example of that in ours. So we'll do gedit and it was opt, oops, John run john.conf. And I'll search for .include. And so the jumbo single rules, that's actually an example of the local include. And we'll see if we can find an example of a file include. Okay, so here are the bypass rules, the rules that come with the bypass project. I included those into John so that you could use the bypass rules in the class today without having to go over to the bypass project and import those rules into the copy of John. Instead, they would just be ready for you to go. So the bypass.conf has rules in it. There's one rule to rule them all, written by a fellow who did some really good studies on the most effective rules from different tools. If somebody has Google, somebody look up who wrote the one rule to rule them all, if you would. The name escapes me at the moment. And the best 126 rules is a rule that I created that is the best 126 rules that I found in testing that I was doing. So, but anyway, these are examples of how to include other files and pull them into the conf file so that you can use them. And I can show you what this looks like so you can see what's getting pulled in. Whoops, that's not what I meant. Here, just do it this way. So, not surprisingly, bypass.conf looks a little bit like the john.conf, and it's just a bunch of rules and labels to group them together. So we have the slow hash rules, and the slow hash phase 2 rules, and the slow hash phase 3 rules. So these are all rules that I wrote that do different things, like, you know, uppercase and prepend 0 through 9, uppercase prepend 2 digits, uppercase prepend. Actually, this is kind of interesting. This will go back to what I talked about be careful about the ordering. So what do y'all think that rule does? Let me give you a hint. The character, the caret symbol, that means prepend. It means put it on the front. It's the counterpart to the $sign, which means put it on the back. So read the rule left to right carefully and tell me what the rule does. What's the first thing it does? Uppercase. What's the second thing it does? Puts on a 3, and then it does what? Puts a 2 in front of the 3, 1 in front of 2. It's 1, 2, 3. 1, 2, 3, uppercase, and then the word. Yeah. So you have to be, again, don't overthink it, but you got to be careful to think through what you're actually typing, because it's quite literal. You know, it takes you very literally what you say. It may not always be what you mean, so just always test the rules. So now you see an example of pulling in another file that someone else already wrote for you that you can take advantage of without having to reinvent the wheel. Or you can organize your work by putting your work in different files that make sense and then pull the files in so to keep the files, you know, kind of tidy and not have them get so long.
I have a person's name, but it looks like it's notsosecure.com.
Notsosecure.com? Okay, thanks. So credit to them for the one rule to rule them all, which is a good set of 50,000 rules taken from a whole lot of other sets of rules. And they did research and found out which of the ones were most effective. So, all right. And they worked pretty good. They did a good job. Of course, everything is situational, so it's not like anyone can make, you know, the definitive top 50,000 rules because the context matters. But when you make 50,000 good rules, you're probably going to get a lot of context. So they did a good job. So we're going to create rules that match the target system. That's our strategy. That's been our strategy all day, is we're going to do everything that targets the target system, because we're going to learn everything we can about the target system, and we're going to focus all of our efforts and energies towards that particular system, the one that's in front of us right now. Cool and Recon NG are excellent tools for pulling in words and patterns and things that you can do the rules on. So now you're going to do lab. This lab actually spans 2 slides. So we'll walk through it. So you're going to create the add 1 digit rule for yourself. You're going to test it and make sure it actually works and does what you expect it to do. And then you're going to use the add 1 digit rule on level 2 type 6 SHA-512 crypt. You're going to crack that file with your add 1 digit rule. You'll need a word list. And what I would suggest is the word list is from this point forward, what I would do is I would start to use bypasses word lists. They're very, very highly optimized and heavily tested, and they do work pretty well. So I would just start using, I would use the top 1,000 English words with the add 1 digit rule and throw that at the type 6 hashes. Type 6 hashes are slow, so you got to be smart about your approach with them. You can't just throw the kitchen sink at them because your CPUs are not going to have time to do all that. In the second part of the lab, not really second part, but when you get done writing your add 1 digit rule, what I'd like you to do is just go back to the rule and just write it a different way. Pick any other way you want. You can use this. This is 3 different ways to add 1 digit. So you have the $, 1 through 5, 7, 8, 9, 0. You have the $, 0, -9. You can use the A through Z quotes 0 through 9. You got the really, I don't know, I guess you call it the explicit way of doing it. $1, $2, all the way down through $9 through $0. Whatever. Just do it a couple different ways just to confirm that you really got the idea down about how to write a very basic rule to start with. So. All right, so to do lab, we type in op John run, John the Ripper, John, and then we're going to need a word list. And we said we were going to use bypasses word list for this one. The add 1 digit rule, and then we have to specify the file as always. So this was level 2 and it was the SHA-512 crypt. If John's running for on a hard problem and it's running for a while and you kind of want to see how far along it is, if you hit the space bar, then it'll kind of give you a report. Also, another thing you can do that works on some hash types, it won't work on it, like it works pretty good on MD5. If you have more than one processor, sometimes you can spread it out. This is a little bit of an advanced technique, but you can spread it out over multiple processor cores and do like a fork. But like it only works on some hash types. Other hash types you would use like OpenMPI. But anyway, just a kind of a tip for these. And being able to hit the enter key will just give you a way of kind of keeping an eye on what's going on as it's running through these. So did anybody notice a major difference between cracking a type 6 SHA-512 crypt hash and trying to crack, say, the MD5s or the SHA-1s that we were trying to crack earlier? Well, like what really stood out? There's only 3 hashes in this file. It's half as many as the MD5. Takes a lot longer. The reason is that the SHA-512 crypt not only uses a SHA-512 hash, but it uses like 1,000 rounds of that hash, which costs a lot of CPU cycles. So for every guess that you're trying to generate, you're having to spend, millions of more computation cycles in order to make that one guess. So it's a way of making password cracking more difficult. The other thing that the SHA-512 crypt format does is it salts the hashes. And it's a unique salt per user. So there's no way for John to hash like the word password and just compare it to every user in the list. it has to hash the word password with the salt for user 1 and compare it against user 1's hash. Then it has to salt the word password using user 2's salt and compare that hash against user 2's hash, and so on and so on. So it doesn't really matter that there's only 3 users. The fact that they're uniquely salted means 3 times as many guesses have to be made, as if either there was no salt or there was a common salt. So having a unique salt per user is an effective way to raise the bar a little bit against password cracking. While we're waiting for this to finish, I'll go ahead and skip to the punchline when it comes to password. Like, what do you do about this problem where passwords are getting easier to crack because the computers are getting more powerful and cheaper per unit of power? If it really matters, if you have a system that you care about, your bank, your brokerage, maybe could be your LinkedIn or your Facebook or your Twitter, could be Google, Gmail, Apple, Azure, whatever. You really need to use two-factor authentication. There's really no excuse. It's free. Every single one of those companies I mentioned, plus a whole lot more, all offer it at no charge at all. There are some banks that don't necessarily offer it. I just wouldn't do business with them because there's so many banks that will, and they'll give it to you for free. You do have to ask, usually. If they're not going to just give it out to anybody, because most people, probably don't even know how to use it, right? But the idea being that you definitely want to use two-factor if you can. So if you have a Gmail or a Google, an Apple or a Facebook or a LinkedIn or a Twitter, if you have any of those. Amazon, yeah. Oh, yeah, Amazon. That's a really good one. Thanks for mentioning that. Go ahead and get that two-factor set up tonight with your phone. All of those all take the phone. Google will also additionally take Google Authenticator, so you can do it offline if you don't have your phone with you. Well, not actually, you still need to run Authenticator on your phone, but if you don't have SMS, like cell tower, you don't have cell access, you can do SMS. You can even have Google call you on a landline. So a voice just speaks the code out. So.
And we've seen a huge increase of Office 365 accounts that have been compromised, and they're using legitimate to send phishing in.
Mm-hmm.
And 100% of them, when we call the vendors and talk to them, none of them using two-factor because it's
yeah. I mean, nowadays it's so cheap and it's so widely available. There's just no reason not to do it. Frankly, for most people, the reason they haven't done it, they just don't like change, or they're lazy, or both. Or they don't like to change from being lazy. I don't know. But anyway. Okay, so we got we got 2 out of the 3 users cracked using that technique. And there's another password that we were not able to crack using that rule with that word list. So a hint I'll give you is the rule is the right rule to use for sure, but you may have to use a better word list or a different word list to crack it. The reason I chose that word list is it is effective on a couple of them, and it's relatively short at only 10,000 words, and you can see how long it takes to even run through 10,000 word dictionary. There actually is a full copy of the English dictionary in Bypass, and that would definitely do the trick, but at 500,000 words, it's going to take a while. So we will leave that exercise to the reader.